Hey guys, welcome back to my YouTube channel. In this video, I'm going to discuss about definite integrals. Given a function f of x that is continuous on the interval ab, we divide the interval into n subintervals of equal width, and from each interval, choose a point. Then, the definite integral of f of x from a to b is denoted the limit by this symbol. The numbers a and b are called the lower limit of integration and the upper limit of integration respectively, and f of x is called the integrand. So there are possible interpretations of definite integrals. One of it is that definite integral is to find the net area between the graph of function f of x and the x-axis on the interval ab. Another interpretation of definite integral is sometimes called the net change theorem. This interpretation says that if f of x is some quantity, so f prime of x is the rate of change of f of x, then the definite integral of f prime of x dx from a to b equals f of b minus f of a is a net change in f of x on the interval ab. So let's start taking a look at some of the properties of the indefinite integral. The first property, we can interchange the limits on any definite integral. All that we need to do is tack a minus sign onto the integral when we do. The second property, if the upper and lower limits are the same, then there is no work to do. The integral is 0. The third property, so as with limits, derivatives, and indefinite integrals, we can factor out a constant. The fourth property, we can break up definite integrals across a sum or difference. The fifth property is that this property is more important than we might realize at first. One of the main uses of this property is to tell us how we can integrate a function over the adjacent intervals AC and CB. Note, however, that C doesn't need to be between A and B. And lastly, the sixth property is that the point of this property is to notice that as long as the function and limits are the same, the variable of integration that we use in the definite integral won't affect the answer. Let's do a couple of examples dealing with these properties. Example 1. Given that the definite integral of x squared plus 1 dx from 0 to 2 equals 14 over 3. Evaluate the definite integral of x squared plus 1 dx from 2 to 0. So, in this case, the only difference between the two is that the limits have interchanged. So using the first property, it gives that the definite integral of x squared plus 1 over dx from 2 to 0 equals negative 14 over 3. Example 2. Evaluate the definite integral of x cubed minus x sine of x plus cos x over x squared plus 1 dx from 130 to 130. So, there really isn't anything to do with this integral once we notice that the limits are the same. So using the second property, this definite integral equals to 0. Example 3. Evaluate the definite integral of 10x squared plus 10 dx from 0 to 2. So for this property, we notice that we can factor a 10 out of both terms. And then, Put the 10 out of the integral using the third property, since it is a constant. Then, integrate it. So, the answer will be 140 over 3. Example 4. Given that f of the definite integral of f of x dx from 6 to negative 10 equals 23, and the definite integral of g of x dx from negative 10 to 6 equals negative 9. Determine the value of the definite integral 2 of x minus 10 g of x dx from negative 10 to 6. So we will first need to use the fourth property to break up the integral, since there are two functions. And then use the third property to factor out the constants 2 and 10. Now, notice that the limits on the first integral are interchanged with the limits on the given integral. So switch them using the first property, adding a minus sign. And once this is done, we can plug in the known values of the integrals, so our final answer is 44. Example 5. Evaluate the definite integral of t squared plus 1 dt from 0 to 2. So in this example, the only difference is the letter used. And so this is just going to use property 6. So just integrate, then simplify. So the final answer is 14 over 3. So that's it for our discussion about definite integrals. If you have any questions, clarification, and suggestions, kindly comment it down below.